Let's see, show of hands of people who are going to show something. Tony, Cam, Brandon, I don't know your name. What? Rohan. Okay. Who else? Boris. Okay, I'm gonna do a quick show of my gripper. Okay, that'll be good. Who wants? You want to go first, Tony?
Or the website here practice.
Okay, good.
Okay. So. Yep. So. Okay. As you may know, I recently started at Stanford. And at Stanford, we have this sort of annoying, somewhat useful thing called Intro to Humanities. And it's sort of a course where people read like old philosophy texts and stuff, and it covers a topic. My topic was humans and machines. I lucked out on that one. And so we wrote some essays and stuff, but then we had a final project, and we could basically do whatever we wanted for the final project, so long as it covered course material. And having a turtle bot, well, we had to use the turtle bot. And so what we decided to do was to explore what people think when a robot becomes human using the turtle bot. And so what we did is we modified our turtle bot with our with a web control interface and our and this very large poll structure. And we put an Android tablet in there, and we made some software so you can remote control it. And our goal was to perform sort of a Turing test. If you've heard of the Turing test, it's where a computer pretends to be human, and when the human can't tell whether they're talking to a computer or a person, then the computer's intelligent. What we decided to do was we took the TurtleBot and we had different scenarios, and we went up to just random passersby, and we'd see what they do. We see what they thought of it. So after they talked to the robot, we chased them down and interviewed them to see if they thought there was a human in the loop or not. And there were 4 conditions. The first set of conditions were conditions where people, we were controlling the robot and using our own voices over Google Voice chat to talk to people. On the other conditions, we were using text-to-speech software, which I'll demonstrate in a minute.
Hello, I'm TurtleBot.
So yeah, it was louder in the actual event. But the other thing we did is we had another row of 2 conditions. In those conditions, we were using either we were generating responses, we would listen to what people said, and we just say what they said, say stuff to that. In the other set of conditions, we were listening to what people said, and then typing that into a chatbot program, and then either reading back what that chatbot said, or we were using text-to-speech to read it back. And I'll demonstrate, and we had some interesting results. When there was a human in the loop with the human voice, 100% of participants said that there was a human in the loop. When we put in the chatbot program, and we were still reading back the chatbot said, that number dropped to 30%. And you could tell people were just freaked out. It was like the uncanny valley, because people would walk up to the robot and then they just like say one thing to it and then run. In fact, we had problems tracking people down because they were biking away past the we could catch up to them. Then whenever you had the chatbot, when the text-to-speech, it didn't make a difference. It didn't really make a significant difference. About 10% of people in both cases thought that there was a human in the loop, and 90% thought it was completely autonomous, which we thought was very interesting. So I'll demonstrate the chatbot now.
Hi, my name is Elbot. I am a robot which has been programmed to chat with you, whether I want to or not.
So that's an example of the chatbot. Does anyone have anything to say to our TurtleBot?
How does it feel to be a TurtleBot?
How does it feel?
Oh, just to be a robot. Questions?
How should I feel as a robot? How does it feel to be human? And how can you even know for sure, unless you have been something else before you were human.
So we have this sort of existentialist chat on downloaded. So that's about it for this project.
Yeah, so what do they see on the tablet? Is it a face?
So I forgot the tablet, but what we sort of display is an image of a, we were going to try and have video feeds going in there, but we decided that was kind of useless, and we kept having Wi-Fi crashing. So what we decided to do was put a image of a, like a stylized robot face, like sort of like a cartoon robot face that smiled at people.
Did that interact at all, or is it static?
We were experimenting with having it interact, but again, the Wi-Fi on the tablet kept crashing, so we decided to have it not interact. Yeah, so I will show my other robot really quick. The robot actually doesn't do anything at this point. So, as you know, we have robo games coming up. I hope you're starting building / planning for that. This is my Robo Magellan entry. It's a new base. It's based on an old RC car I dug up, and a propeller as the controller with some sonars. And then I've got a phone, which I'll be using, an Android Motorola Zoom phone, which will serve as my brain / GPU / vision recognition / cameras / gyro / compass / accelerometer / GPS. Basically everything you want for Robo Magellan except sonars and on sensors and motors is in a phone.
Does it have enough horsepower to run it?
It's a 1.2 gigahertz dual core, which from my experience with the OLPC should be excessive.
Even for the vision?
Yeah, it's actually not too bad. The other feature, the other thing is that there's a lot of pain involved in getting an Android phone to talk to a USB to a device such as a microcontroller. There's this great stuff called MicroBridge, which basically allows any arbitrary Android phone, even the very old 1.5 phones, to talk to a propeller or a microcontroller by exploiting the debugging interface of the controller. And so you might want to check that out. I posted a link to it on the HPRC list. That's about it. Thank you.
Question on the microbridge thing?
Yeah.
So I've heard of similar things like yo-yo board, and there's another one too.
80K.
Yeah,
the 80K. Yeah. So how does this differ from those guys?
I forget exactly how the 80K works. Some of them work similarly. This is just a program that you can download for a propeller that will do it.
Oh, it's propeller code.
Yeah, it runs on the propeller, and then that's that.
No hardware. Okay.
Yeah.
Okay. Yeah, it's the Android source. No,
Very good.
All right, thank you
very
everybody.
much. Very, and as usual,
Then reloading.
another good demo. Okay. Yes, Boris, you're next. Come on, Boris. Well, as you folks know, we have a rule here that when we give something away, you're supposed to bring it back. Boris has successfully done so. So I'll let Boris take over.
So recently, probably like 2 months ago or 3 months ago, I got a Nano ITX board from this club. So I made a computer and made an enclosure from a project box from a craft box from Michael's. I cut holes for the ventilation and yeah. I've installed a special version of Ubuntu called Black Ubuntu, if anyone knows what that is. No one knows what that is. It's a special version of Ubuntu which has tools for penetration testing, which is very useful sometimes. So I've downloaded, installed ROS on it, and I have Magneto there. Magneto XV11. I got the Nito node running, and I still have problems with the navigation. And yeah, that's all.
Were you able to get the RViz run and get a radar map with it?
No,
Okay.
I get warnings on the navigation, and something's up with my RViz. I don't know what.
Okay.
Okay, that's all.
Keep posting it.
Okay, since we had so much success giving that away, we have 2 giveaways here. We have a Spartan 3E FPGA starter kit. So if anybody has ever wanted, okay, it's gone. Osmond gets the FPGAs. So could somebody help me hand it back? No, I can't do it. Let's run it around that way. Now, usually we want everything to come back. We've got something here called Programming Microsoft Robotics Studio. Anybody who wants it can have it. I don't care if it comes back. Okay, here you go. Okay. We've got camp. Let's do camp now.
All right.
We like to encourage people with small children to come up here because this is so they can see better. Okay.
Robo Games is April the 20th through the 22nd, and it's already
There's 3 chairs
February,
right there.
basically. Hey, is there a marker? Is there a marker around here?
Come.
Is there a marker, whiteboard marker? I guess not. Okay. So this is a club bug. The club bug is the little table bot that we've built for the challenge. And what I've done is I'm trying to add some intelligence to it. So I've basically stripped away the bumper, and I've added a iRobot stasis sensor, which I prefer to call a mobility sensor. Regardless, depends on how you look at it. And what I want to do with this is an example of a book that inspired me when I was young, called How to Build Your Own Self-Programming Robot by David L. Heiserman, tab number 1249, 1979, regardless, wherein he describes 3 levels of machine intelligence. And he describes them as class alpha, beta, and gamma. And when you're driving a differential drive robot, you've got 9 possible motion codes, 9 possible motions, including stop. Okay. Left wheel forward, left wheel right, left wheel reverse. The only 2 motions with any displacement, however, are forward and reverse, and that's what our mobility detector is going to tell us, is when this robot's going forward and reverse. Now, at the alpha class, which this robot currently is, you will see the robot basically just thrash around, trying to go it's trying to. As long as the encoder's moving, the robot's happy. When the encoder's not moving, it's going to randomly try these 9 different motions to get the wheel moving. And so here you can see it, stall, try different stuff, and then finally it picks up on, forward, okay, and there it goes. So it's actually a little more interesting when you set it in, any environment. This guy, it'll bumble into any enclave trap, and it will, eventually bumble around until, it comes back out. The intelligence here involves learning. So the alpha level is random. The next level, when it's in a particular motion and it learns either forward and reverse, it will remember that. And the next time it's in that motion, it'll try that at reaction again. If it is again successful, it will increment its confidence level. If it's not, it will decrement for a high level confidence of 3. I'm working on an array here where I've got my motion codes, I've got the successful reaction to given motion code, and then I have a confidence level. So that again, alpha is random, where the robot randomly learns forward and reverse. Beta, it will remember a successful response. So when it's in a motion and it had a successful response, it will repeat that and increase its confidence or decrease its confidence level. The gamma model, the robot is experiencing a particular motion and to which it has no reaction. It will go to a high level beta response and try that before devolving into alpha level random motions and thereby learning. So when I show this again, I should be able to see it incrementally learn forward and reverse faster and faster. Thank you very much.
Okay, very good. Okay. You got something for us tonight? Excellent.
Marlene, the robot's name is Scaffold, right?
Okay. What do you have for us tonight, Brian?
Speaking of a robot that doesn't work yet,
Okay, that's okay.
this is a project that a few people from the club here have been working on, and possibly a few people from NITO have been working on. What this is going to be, actually this is going to replace my white cane. That's my goal, is to throw this out the window. But what we're working on is, of course we're using an XV11, but we're working on a robotic guide for the blind. And we picked this device here because it has so many sensors. And we've been working with Carnegie Mellon, NITO, and some of the club members here. And we meet Tuesdays. We put this Yahoo group together called Clear Path Navigation. And so we're trying to solve the problems that is surrounded by what does the blind person need. And so we chose this as our base for a prototype. I'm working on trying to secure funding to do this and creating this whole, hopefully someday there'll be a whole business around this, providing robots. Because I think if we look at the robot world, I think one of the little niches for that will be assistive robots for people with disabilities. And I think this is a very interesting project. We've been batting around concepts. Some of our software engineers have been figuring out what we need. I work in blind rehab at a blind center, and so I've been tasked with figuring out what do we need, what sensors do we need, what are the things that we navigate this smart world that we live in. What are the sensors that we need? And we've figured out about 6 or 8 sensors it'll take to accomplish this task and get a person who's blind or visually impaired from point A to point B. I think one of the things I read is that travel is one of those unconscious skills that everyone has, and you don't even think about it. If you're going to go from here to your car, you just do it. You don't really figure out, well, I've got to exit this room, I've got to navigate through all these things in this room, find the hallway, and get outside, get down steps, make a right turn, left turn. And so this is our challenge that we're working on. And this, hopefully someday we'll come back with a full working model.
That's excellent. Very good.
What do you envision like for transport for that thing? 'Cause like that doesn't look like it's going to go downstairs very well.
Well, that's personally, I don't think that's an issue. Because once this gets you to the drop-off of the stairs, you can pick it up and carry it down the stairs.
Oh, okay.
Because the stairs are consistent, an 8-inch riser, and just keep going till you hit the ground. There's all kinds of concepts. Actually, Japan is working on, if you Google CNI robot guide dog, they've got this huge it must be, probably this tall by the look of the photos. It's accomplished going downstairs, but you got this huge thing that you got to go like this to get anywhere. And I really feel that a lightweight, sensor-rich platform like this to be able to detect all the navigation that you need to do for me, I think it's the answer. So.
Are you looking for additional people who would be interested in joining?
Yeah, anyone that's interested, you know, we can get you. I can get you the information. It's a Yahoo group, and guys can correct me if I'm wrong, but it's Clear Path Navigation software. Dave.
Is there any chance that we could get you to submit and mail that to the list?
Yeah.
Okay.
Yeah, I can send that out.
Okay. Why don't we do that so anybody who's interested can see if they want to join it?
Yeah, just a comment, an interesting coincidence. The company that's putting together the kits for the Turtlebot is Clear Path Robotics in Canada. So that's the name of it.
Okay. Cool.
Thank you.
Thank you very much, Brian. Okay. I'm starting to sweep here. Who's next? We had a big gap, and then we got Brandon, and we had Rohan. Why don't you come on over for Rohan? We'll come back to Brandon. Power plug. Those are in use. There might be, this one might work right here.
I don't know.
I don't know if it's plugged in.
You can unplug one of the PCs from there.
Yeah.
You mean the one I just stepped on by accident?
Yeah, the one you stepped on and crushed. And
Yeah, that's that one, yeah.
Wait, you can take mine off the bottom.
Bottom one? Okay.
Cannon boom box?
There you go.
Different variation of it.
Is that long enough? We have a problem. Houston, we have a problem.
Move the table?
Move the table.
Move the
Tables
table.
have wheels on it.
Okay.
Don't
Get
drop the
somebody-
phone.
There we go. We need, we've got it. So don't trip on this. Okay.
So here I'm going to show you a variation of my Canon Boombot. I call it the Canon Boomroid because it's controlled by an Android. It right now it doesn't do much, but I'm planning to do all 3 phases of the tabletop challenge with more features, such as taking a picture every time you do something, like for phase 3. Every time you put the block into a shoebox, you can just show a picture of that and then say success.
Very good.
So right now it just moves its little head around.
I see a wire dangling there.
Yeah, that's just no
Okay.
use. You'll see that this little ping sonar over here, it's on a servo. So
There it goes.
So I'm controlling it with right now just the standard demo kit sample app for the Android 80K board. But again, I'm gonna try and change everything around so that
So it's still a Arduino on there?
yeah, I'm using the Arduino Mega 80K board. It's quite simple to use. It's just most of the heavy work for the USB and all of that is done for you in the libraries. You just connect up the cable, use some of the simple library code in both the Android Android app, and then the Arduino program, and it interfaces quite nicely. So I can. It also allows the ADK to talk to the phone, of course. So instead of keeping all my heavy logic on the ADK board, I can put it on the faster phone. That way I get more response out of my robot. So if it gets to the edge of a table, it knows that it's at the edge of the table more quickly than it would on the ADK board. So I'm still gonna do what I did with my Canon Boombot earlier. It's just Android controlled. So that adds user interface, so the user can say stop right in the middle of it without having to unplug the thing and maybe it falls off the table or something. So that makes it quite neater. And then the pictures, it can just go. So if it wants, it just push the block into the table. It comes out. It just stops, shows a picture of success, and then it saves that picture, and then I can just upload that on Flickr or something.
Sounds good. Yes, Boris.
That would be awesome if it could automatically upload it to Facebook or Flickr. Takes a picture, uploads it.
Yeah.
Will it add me on Facebook?
Friend me. Okay. Anything else? Okay. Thank you. Very good. I'll push that. I'll take care of that. Excellent. Okay, Brandon.
So this is a revision of the cell phone with legs. Basically, it's a new phone dock. Basically, that we have two additional versions. One that has tracks and one that has wheels. And then Brandon has created we took the original kind of little interactive robotic pet personality guy that lives on the phone. We have two versions. There's a boy and a girl, and we've enhanced it now so that it can interact with an individual. So it interacts with faces. So the first thing that it does is it looks around for a face, and then when it finds a face, it'll try to come over and interact with you. And then Brandon's been reading this book by Cynthia Brazil. What's the name of the book?
I don't know, something like
Social Robots, right? That was it, right? And so in her book, she talks a lot about like robots getting bored and maybe wanting different things to do, and in order to make them sociable, it's interesting if they come over and they want to interact. So that's kind of the idea here, is that it'll eventually, at first when he starts it out, it'll get interested in Brandon, and then it'll start asking to see some of its toys, which we have some little toy boxes. There you go. And then if Brandon presents it with the appropriate toy.
So I'll start it up here. So I wake it up, and it says, oops. Trying to turn up the volume. Okay. So he says he's happy. He's looking for somebody. So if I look at him, and actually, I turned him off. So I start back up again.
Misbehaving.
Yeah.
Battery problems.
Okay, so he says, where did it go? So, and he sees me. So if I get up close to him, he like runs away. If I back up, he starts coming forward. If I move over here, he'll kind of follow me around. That's fun. And then once he finds me, he says, "I want a blue toy." And he's seeing green everywhere. So if I show him a blue toy, okay, so now he sees the blue toy. And, if I get too close again, he'll back up. Otherwise, he can chase it around. So he's following it here. This way. Back up. So he has different colored toys. He doesn't like green. I think all these green cables, it's seeing a lot of green, but it does see the blue. And now he's coming forward. Then, he does like a little dance. So yeah, so we got, two different models. We were planning for these to be kits that we would sell. And so, we got the wheels and the treads. And, the smartphone adds a lot of extra features to it. So we have that. And there's other apps I have running on here.
Oh, right, yeah. So Brandon also got the Cellbots project running on this. So it's something that Ryan and his guys here at Google have been showing off a while back. And so it actually turns the little robot into a teleoperated critter that he can drive around and see basically live video coming from the phone in his hand, and then use that to drive the robot around in a teleoperated manner. All it takes is having 2 cell phones.
How are the 2 phones communicating?
Via Wi-Fi, and
it's a different. I have to redo the Wi-Fi.
Oh, right, it's a different network.
Right.
So the Cellbots project actually is interesting because the way that it works is you the phone connects to whatever the Wi-Fi is, and then you can say, "I want to talk to you, robot," and it'll actually display a QR code up on the screen that you can scan with the other phone, and it'll automatically suck down all the data of like its IP address and the port and everything that it's on. So it doesn't matter. Getting a new robot working on a new phone is pretty easy. So like right now he's going to scan the QR code for the robot.
So there's a QR code on here, and I can scan it here. It's got it. So now it knows what its URL is.
Right. So this kind of eliminates a lot of the infrastructural issues of if I have a Wi-Fi connected robot and I'm on an unfamiliar networking environment like we just came in here to Google, it'll
And I
just
forgot,
work.
I gotta turn his head sideways.
Oh, right.
Now you can see it goes kind of fast.
Yeah.
So, but I have a live picture on here. If I turn around.
Yeah, drive this way. Straight
Right, so
ahead.
it sees Ted.
I see. I'm right here.
There's Ted on the phone, so I can drive towards him.
And then he can also change the expression of the little face, the little character on the phone. So right now it's not really seeing anything. Oh, now it's happy. So, and this is all stuff that the Cellbots project already did. It's just out there. You can download it. It's open source. It's pretty straightforward to get working.
2 questions. How is the phone and the robot communicating?
Bluetooth.
Oh.
So he's Wi-Fiing to the other phone, and then the phone is Bluetoothing to the dock.
And What version of Android are you running?
So these phones have 2.3, probably 2.3.4 on them, but I think 2.2 would work fine. So,
Cool.
yeah.
Great.
Very good.
Nice.
Okay, any more robots for show and tell? Melanie?
Can I just make an announcement?
What? Sure, go ahead.
Hey, TurtleBot users. I've been looking for TurtleBot developers. I know you guys have been using TurtleBot. I have some big goals for SquareTrade, raw SquareTrade, to get TurtleBot to 1.0 to get stable. And I have about 44 tickets to close, and I'm men down right now. Just Melanie as a developer, and I could really use some help. So if you're interested in working on TurtleBot, writing code for it, I'd love to find out and get you involved in closing tickets for TurtleBot. I have cool swag for you if you become a contributor. I have a cool patch and maybe a vinyl sticker or two. You know, write me a letter. Tell me what you're looking for in terms of TurtleBot swag. I can't give you a full TurtleBot, but I might be able to give you some iconic. I don't think Steve would like to swing up here to the TurtleBot. Yeah, maybe some Pure chocolate. But if you are interested in doing some TurtleBot development and using TurtleBot, I'd really love to get in touch with you. We're trying to grow our community in terms of developers, and so it would really help. Great. And if you don't know my email, it's mwise@willgarage. So, or you can just go to any Ross wiki page and probably look me up really quickly.
Melanie, we have a larger community on our mail list, so please send a message. Okay. Okay. Good. Any more robots? Otherwise, I'll be the closer here. This is the hand for my robot. Okay, it's got two movable grippers that can be moved either side by side or back and forth. Okay, and if you were on the mail list, we talked a bit about soft pots for measuring position. So if you look through here, it's white on white, unfortunately, but these two bands of white here are the soft pots, and then if you come up and look at this thing, there's a soft pot pushing down there and down in there, okay? And then it's got two motors driving standard 1/4-20 threads, so they're kind of slow. I wish I could get a pitch that's a little lower than 1/4-20. What? Oh, 1/4 inch diameter and then 20 threads per inch. Okay. And then just a couple of motors, and then for those of you who know, I do RoboBricks, and I use RoboBricks to drive these things. So anyhow, I just thought I'd let people see my work in progress. This goes on my robot, which is taller than I am. Okay. What?
Does this go on your scar arm that you presented?
No, this does not go on my scar arm. It goes on. I have never brought it in because it's big, okay, and it's about this tall, okay, and it's heavy, and so I don't bring it in. But the goal is here to have something that can lift up, 10 to 20 pounds without really pushing it. So, I didn't mention inside these grippers are force-sensitive resistors. So when it's grabbing something, it senses it's got something in there and it can stop squeezing. Okay. So, any more questions? Okay, with that, we are going to go to our talks. Okay, we usually let people do a quick bio break if they want to go to the restroom. The restrooms are down there. You turn left at that really cool vending machine that Google has. Go down that, right, and then you're at the restrooms. Okay, and then we're going to start off with Alan. Okay, and you can do your setup while people do the bio break, and then we'll get going.